If the intercept of the crystallography axes are 0.5 A, 1 B, 0.7 C. So intercepts are given, write down in terms of ABC, 0.5, 1, 0.75. So you have to calculate the crystallography plane scale, the value of L. So you just take the reciprocal, 1 by 0.5, 1 by 1, 1 by 0.75. So it will be 1 by 0.5, it will be 2, then 1, then it will be 4 by 3. So to simplify this, we will multiply 3. So it will be 6, 3, 4. 6, 3, 4. So 6 is H, then K, then L. So L will be 4 here. L will be 4. Answer will be 4. The density of a FCC unit cell, it is given 6.5 gram per centimeter cube. If the mass of a single atom is given here, then the diagonal length of the face we have to calculate. So the density of the unit cell as a formula, that is rho is equal to mass into number of atom present within the unit cell divided by Avogadro's number into volume of the unit cell. So Z here indicates number of atom in unit cell. Here FCC, so Z will be 4. Then M is your mass, it is given 60 gram. Then Na Avogadro's number, it is given 6.022 into 10 to the 23, and A is the side of cube. Side of cube. So rho is given 6.5 gram per centimeter cube. So we'll put the value now, 6.5, then your 6.5 gram per centimeter cube, then mass is given 60 gram into 4 divided by 6.022 into 10 to the power 23 into a cube. We have to find out the side. So it will be a cube is equal to 60 into 4 divided by 6.5 into 6.022 into 10 to the power 23, this much centimeter cube. So here question is asked in answer is asked in angstrom. So we have to convert this centimeter cube into angstrom cube. So the 1 centimeter is equal to 10 to the power 8 angstrom. So if you convert this centimeter cube, that means 1 centimeter cube, it will be equal to 10 to the power 8 angstrom cube. Okay, so you can write down here also. First we'll solve this part. It will be this much, 6.131 into 10 to the power minus 23 into 10 to the power 24 angstrom. 10 to the power 8 the cube, that will be 10 to the power 24 angstrom. Okay, so you can write down here 6.131 into 10 angstrom. So AQ will be 60.31 angstrom. So A will be cube root of 60.31 angstrom cube. So it will be 3.921. So this will be the side. So if you know the side of the cube, we can calculate the diagonal. So diagonal will be 3 root 2a. So root 2a. So it will be 5.54 angstrom. The answer will be 5.54. 54 angstrom. That is the diagram. If a mineral with formula KAl3Si3O10FOH So it's the same general formula. You can write down X, Y22, 3, Z4O10 OHF whole 2. So your F is 0.5. So how much required for 2? So it will be 1.5. So OH will be 1.5. Then the atom percent of Fe in pyrohotite. So atom of Fe, it is given 0.77 S. So number of atom of Fe, it is 0.77. Number of atom of sulfur, it is 1. So number of percentage of Fe atom, it will be 0.77 divided by 1.77 into 100. Will be 43.50. Then the mole fraction of phosphorite in olivine with MgO 29.17 weight percentage, FeO 34.65 weight percentage, and SiO2 36.18 weight percentage. So you have to calculate the mole fraction of phosphorite. So MgO weight percentage given to 29.17, then FeO weight percentage it is given 34.65. So first we have to calculate the moles of phosphorate, moles of MgO and FeO. First will be moles of MgO here. It will be given mass, that is 29.17 divided by molar mass, it is 40.31. Then we have to calculate the moles of FeO, given mass 34.65 divided by weight is given 71.85. Moles of MgO will be 0.7236, moles of FeO will be 0.4822. So then we'll calculate the mole fraction of phosphorite, will be 0.7236 divided by 0.7236 plus 0.482 will be 0.59. So the mole fraction of MgO will be 0.59. So that is indicate the phosphorite. For an anisotropy crystal, thickness is given 0.04 mm. The refractory index, N1 is given, will take 636, and N2 it is given 1.486. So the retardation will be thickness into birefringence, N1 minus N2 will take here. So thickness is given 0.04 mm into, it is given 1.636 into 1.486. So this will be minus, sorry. So 1.636 minus 1.486, it will be 0.006 mm. But answer is asked in nm, so it will be 6000 nm. Because 1 mm is equal to 10 to the power 6 nm. Answer will be 6000 nm.